This week we learned about 3 direct variations, Hooke's law, Ohm's law, Newton's law, and today we're going to learn about the one and only inverse variation, which is Boyle's law. Again, our content is math models with applications, MMA, and our topic is going to be Boyle's law, B-O-Y-L-E-S. Okay, so Boyle's law says, if the temperature is constant, so we'll talk about the temperature is not going to change, then the volume of an ideal gas is inversely related to the pressure of the gas. Okay, so Boyle's law is represented by PA VA equals PB VB, where P is the pressure and V is the volume gas. Okay, so you're going to notice that a lot of these things are going to change as far as pressures. Okay, so we have a party balloon with a volume of 3.0 liters is filled with the helium gas at 4 atmospheres of pressure. The temperature throughout remains the same. Use Boyle's law to determine how the volume of the balloon changes if the pressure of the gas is reduced to 1 atmosphere. So again, what I've taught my students is that they need to organize their information. So we're going to come over and we're going to do pressure and volume. That way we can see what's going on with our data. Okay, so we got a balloon, has 3 liters, that's the volume. And it has 4 atmospheres of pressure. So, all right, they want to know what happens to the volume. So it's there if the gas is reduced to 1 atmosphere. So VA equals PB, BB. We could do P1, P1, V1 equals P2, P2, V2. Either way, we have two separate pressures and volumes. So our first one is going to be 4 atmospheres, ATMs, times 3 liters equals 1 atmosphere. Let's move some stuff here. So this, let's move this just out of the way a little bit. Down there. Okay, that's this. Atmosphere. Times the volume. Okay, so we can let's see, 1 atmosphere and how many atmospheres? So we're going to divide both sides by 1 atmosphere. Here. About 1.0 atmosphere. Atmosphere. We can divide our atmospheres, and what that's going to leave us with is liters. All right, so 4 times 3 is 12, divided by 1 is 12. So we're going to have 12.0 liters is going to be our new volume. So as we can see, that this decreased by 4, by a factor of 4. So this went down by 1/4, and this increased by multiplied by 4. So we took 3 times 4 to get this. This one went down by 1/4. So it says determine the changes. So we have over here that it's going to be now 12.0. All right. So they want to find out the resulting pressure on the balloon's volume if the original liters has been changed. Find the resulting pressure if the balloon's volume changed from the original 3 liters to 1.5 liters. So we still have this lovely little setup over here. So we can just extend it. Screen this time. So I'm just going to extend it. It says, what happens if we changed our volume instead of our liters? You know what? I want to see. I want to do the visual even better. Let's do pressure, volume, 4.0 to 3 liters, and we're going to change the pressure from 3 liters to 1.50 liters. And they want to know what's going to happen to this. Well, this has went down by 1/2, so this should go up. That's what inverse means. As one goes down, the other one will go up. So I'm going to surmise that it should be like about 8, but let's go find out. So PA, BA equals PB, BB. We have 4.0 liters times, 4.0 atmospheres times 3.0 liters equals pressure. We don't know this, but we're finding out. And I'm going to stick it also this to get stuff out of the way. Go. All right. And we have, we don't know what our new pressure is, but we do know that we do have 1.50 liters. And we are going to divide out 1.5 liters. 1.5 liters. Away the box is by itself. Divide by 1.5 liters. We can get rid of our liters. And we're just going to take, a little calculator, 4.0 times 3.0 equals 12. And then we're going to divide that by 1.50, which gives us 8. 8 spheres equals pulse. Okay, with the direct variation, we can find out if we have the correct answer by setting up a proportion. 4 over 8, does that equal 3 over like 1.5? But with inverse variation, we multiply. So we're going to find out if I come up here to the other one, should have done that also. 4 times 3 equals 12. Checks. 1.0 times 12 is also 12. Check. So on this one, 4.0 times 3 equals 12. And let's find out if 8.0 times 1.5 equals 12. It does. So again, we can check what those are off. Okay. All right. So is it a direct or an inverse variation? It is an inverse variation. Explain. Well, we don't have the form y equals kx. We do have that with our inverse variation, it's x1, y1 is equal to x2, y2. And this is EA, VA equals PB, VB. Again, we have a set of variables, x and y. And in this case, it's pressure and volume, which is equal to another set of, instead of x and y, pressure and volume, and we just denote them by a subscript, either 1s, 2s, a's, or b's. All right, so now we've got some practice over here. Well, we got a sample of oxygen gas occupies a volume of 250 milliliters at 740 torrs of pressure. Okay, so with direct variation, we generally have set units, like ohms has set units. Newton's law had set units. Hooke's law didn't, because you could put pounds, you could put kilograms. You didn't have a set weight. But with Boyle's law, we have different types of pressures. We have different types of whether it's a liter, a milliliter. They generally will be reporting them in again, metric form. So last time we had liters, this time we're going to have milliliters. So we have a sample of oxygen gas. It occupies a volume of 250 milliliters at 740 torrs of pressure. What will the volume occupy at 800 torrs of pressure? So go ahead, create our little table over here. Pressure, volume. All right, volume was 250 milliliters. Again, I just want to see this as a picture. 740. What will the volume be? That's our unknown when it's 800. So this is increasing 740 to 800. So this means that the one should decrease. That's why I want that table so I can see that picture. So PA, PA, plus BB, BB, that's 640 times 250 equals 800. I should put my milliliters in there. Oh, that's my pressure. Okay, come back over and we're going to divide results. Divide both sides by 800 torrs. Torrs. All right, just put it out. 740, no, 740 times 250 equals 185,000, but then we're going to come back, we're going to divide out 800. So 231.25. Remember to verify this, we're going to double check. So we're going to clear, we're going to do 740 times 250. This is 185,000. I'm going to find out that's 800 times 231.25 equal 185,000. Yes, they will check. Okay. All right. Still light up blue. A sample of carbon dioxide occupies a volume of 3.50 liters. Pressure, volume, 3.50 liters, 125 kPascals. Pressure. What would the pressure be? So that's all unknown. If the gas would decrease to 2 liters. So this is going to go down. This one should go up. So VA equals PB, BB. So we got 125 pascals times 3.50 equals box times 2.0. All right, then we go back through and we're going to divide through 2.0 liters to get rid of it on this side. Right. We'll have our calculator here. 125 times 3.50, 137.5, and then we're going to divide it by 2.0. So 218.7. We want to make sure that both of those check. Clear. 125 times 3.5 equals 437.5. So our check that we're doing, clear entry, 218.75 times 2.00, 437.5. double check. Yes. That's what they mean by double check. We're going to check it 2 times and that we get 2 check marks. All right, so a 2.0 liter of container of oxygen kit is at 3.2 atmospheres. What would the volume be necessary to decrease the pressure to 1 atmosphere? All right, pressure and volume. 2.0 liter, that's volume. Had a pressure of 3.20 atmospheres. What would be the volume needed to decrease the pressure to 1.0 atmospheres? All right. So VA equals PB VB. Oh, so that's 3.20 atmospheres times 2.0 liters equals 1.00 atmospheres times our unknown volume, which is just going to the box. Okay, come back through, we're going to divide out. 0.00 atmospheres. I got 1.00 atmospheres. Divide out atmospheres. That's the same thing as dividing by 1. So if I just take and multiply 3.20 times 2.00, it's going to be 6.4 divided by 1. I just showed 6.40 liters is what we need to get it down to 1 atmosphere. All right, let's double check. So 3.20 times 2, 6.40, and of course 1 times 6.40 is 6.40 also, so we double check those, and that's what we. All right, so this is inversely proportional. We are always going to double check. That's VA equal PV. Okay, and as 1 increases, other value. Okay, all right, that's it.